How's it going? These are the test scores. Any questions? I mean, I just will say that not taking a test is not like a super great path to success. So don't do that. That's a bad idea. Any questions on the test review from the day before? I did post a video, but if anybody has any other questions on those problems, I'd be happy to address them. Okay. All right, so we have just a couple weeks or a week and a half until Christmas break. So rather than starting a new topic, we're actually going to do a little bit of review. Okay, so there will be a cumulative test on units 1 through 5, which is everything we've done so far, before break. It's a 2-day thing. It's going to be on Friday, 12/18, and Monday, 12/21. I think those are the dates. Friday the 18th and Monday the 21st. And it's going to be basically on everything we've done so far. It's going to be, both of it is going to be on Delta Math, obviously, both of those days. And one thing that's really important to note is there's going to be no test corrections available for these tests, and it's going to count as 2 tests. No test corrections available. So for people that sort of rely on that, don't rely on that. No test corrections for these. Okay. And it's going to count as 2 tests, like I said. So what we're going to do the next few days, the next few class days, is we're just going to review each unit one day at a time. Okay, and just remind you of the stuff that's on it, that was on that unit. And then the homework for that night is going to be just like one problem of several different types from that unit. Okay, just to refresh your memory about what's going on. Okay, and then what I think I'm going to do is after break, once we start unit 6, every test that we take is going to have 1 or 2 review questions from previous units. Okay, just to get you used to like continuously reviewing rather than all at once. That's something I normally do when I write my own tests, but I sort of haven't been doing that this year. And I think it's really good because in the end, it's not like when we get to May and we start reviewing for the end of the year, whether it's a Regents exam or the final exam or whatever, there aren't any topics that you haven't seen since October or whatever. That way it's like more of a continuous review type thing. Okay, so that's the plan. So today we're just going to talk about Unit 1. Okay, Unit 1 review. So these are just the things that we talked about that were on the first test that we took way back in September. Okay. So we started off just talking about the segment addition postulate. So essentially what that says is if you have a line segment and a point that's on that line segment, so let's say this is like ABC, it just says that if you take part of this segment plus the rest of the segment, you get the whole segment. So it's fairly common sense when you look at the picture. It's just saying AB plus BC equals AC. So it should make perfect sense. But the way that these questions are worded are more algebraic. Like they'll tell you like this length is x minus 2, And if this length is 4x minus 9, and if the whole length is x plus 5, they might say something like, find the length of AB. You remember these questions? So all you do is you just set up an algebraic equation. You're just going to use the segment addition postulate to say, if you take the length of AB, which is x minus 2, plus the length of BC, which is 4x minus 9, you get the length of the whole segment, x plus 5. And then it's just solving this linear equation by getting all the x's on one side and all the non-x's on the other side. So this would be like 5x minus 11 equals x plus 5. If you subtract x from both sides, you get 4x minus 11 equals 5. And then if you add 11 to both sides, you get 4x equals 16. So x is 4. And then you just always have to make sure that you answer the question that's being asked. This question doesn't say find x. This question says find the length of AB. They might say, what's the length of BC? Or they might say, what's the length of the whole segment? So you have to be able to answer any of those questions. So the length of AB in this case would just be 4 minus 2. AB would just be 4 minus 2, which is 2. That's the answer to it. Everybody remember those? Okay, that's called the segment addition postulate. The next thing we talked about in that unit was special pairs of angles. And there were basically 3 types of angle pairs that we talked about. We talked about the idea of angles being complementary, which just means adding up to 90 degrees. We talked about angles being supplementary, which just means adding up to 180 degrees. And we talked about angles being vertical angles. And remember, vertical angles are like across from each other in an intersection like that. And the deal here is that these are always congruent. Okay, these problems also were algebraic type questions. Like they might say angle A and angle B are complementary. If the measure of angle B, or angle A rather, is 2x minus 13, and the measure of angle A, B rather, is 4x minus 5, find the measure of angle A. Okay, so all you would do is, you could draw a little picture if you wanted to. It would look like this. Complementary angles would be angles that just add up to 90 like that. That's the picture. Angle A is 2x minus 13. Angle B is 4x minus 5. So what would you do here?
2x minus 13 plus 4x minus 5 equals 90.
Exactly. 2x minus 13 plus 4x minus 5 equals 90. And again, that's just a simple equation that you should be able to solve by now. This would be 6x minus 18 equals 90. 6x equals 108. And x would be 18, I think. So then again, make sure you read the directions and answer the question that's being asked. In this case, they want you to find the measure of angle A. So you'd say the measure of angle A is really 2 times 18 minus 13. So this would be 36 minus 13, which is 23. Okay? If this question was exactly the same, but it said supplementary, what would you do differently?
180.
Yeah, you'd set it equal to 180. If this was exactly the same and it said vertical angles, what would you do differently? Yeah, you just set 2x plus 3 or minus 13 equals 4x minus 5. Does that make sense? So they're all the same thing. You just have to know like what the words mean so that you know whether to set them equal or set them equal to 180 or set them equal to 90. Okay? After special pairs of angles, the next thing we talked about was the idea of a bisector, either a segment bisector which is just a line or a ray or a segment that cuts an angle or cuts a segment in half, exactly in half, something like that. That's a segment bisector. Or an angle bisector. So an angle bisector is just a ray that splits an angle exactly in half. Something like that. That's it, exactly in half. And again, these are algebraic type questions. They'll give you an algebra expression for this half and an algebra expression for this half, and you just set them equal to each other. Or same thing here, algebraic expressions for each of these small angles, and you just set them equal to each other. Or another possibility for an angle bisector is they might give you algebraic expressions for one of the small angles and the whole angle. In which case you would just say 2 times the small angle equals the whole angle if they're telling you it's an angle bisector. Is that logical? So that's angle bisector. Then we had 4 basic constructions. 4 basic constructions. And these are the ones where you use a ruler and compass. And you should remind yourself how to use those tools on Delta Math so that when you get to the test, it's not like you're seeing it for the first time in 4 months. You got to practice it. Okay, so 4 basic constructions. They were copying a segment, and I'll just remind you how each of these work. So if I'm trying to copy this line segment, for example, the process is to draw a ray that's at least as long, and then just use your compass to measure the line segment. You're not allowed to use your ruler to measure a line segment, but you can use your compass. So you put the point of your compass at one end point of the given line segment, and then just make an arc to indicate that you measured it, and then just go down here and make the same size arc. That's it. That's copying a line segment. Does everybody remember that one? Okay. The second one was copying an angle. And again, I'm just doing like a sketch of what the construction would look like in the end, but you would use ruler and compass for these. So if I give you an angle, this for example, and I'm trying to construct an angle that's the same measure, the first step is to make a ray that's like one side of the angle you end up with. Then you go to the angle that you're copying and make any size arc like that intersects both sides of the angle, and make the same size arc over here. What's the final step? The second to last step, I guess. Anybody remember?
Another arc. The top part of it. You make another arc here and then you copy it there, right?
Yes, yes, exactly. You're gonna use your compass to measure this distance right here, right there. You're gonna put the point of the compass here and measure that distance, and then come over here and copy it over to here. Remember that? And then you just like connect the dots from the starting point of your array to that point of intersection of the two arcs you drew. That ringing a bell? The next one was perpendicular bisector of a line segment. So for this one, you're given a line segment and you want to construct the perpendicular bisector of it. You open your compass, how much?
More than half.
More than halfway, right? So you put the point of the compass here and you open it more than halfway. And you make like a little, kind of a large arc like that. And then you just flip your compass around and make an arc going the other way, like that. And then you just connect those 2 points of intersection. It splits the line segment exactly in half perpendicularly. Everybody cool with that? And then the final one was the angle bisector. Bisector of an angle. So if I have a given angle, this, the steps are first make any size arc on the angle centered at its vertex like this. And then we basically do the same construction as perpendicular bisector of a segment, except we're going to do that construction on this red arc that I just drew. So I'm going to open my compass more than halfway, make an arc. Now, there's a little bit of a shortcut. Like, I could draw this whole arc like this. That's okay. And then my compass around and draw the same size arc over here, like centered there. That's okay. Or I could like only draw the right part of this, right? Because I have this other point right here that's going to be a point that I can use to connect. I don't necessarily need both of these points of intersection of the arcs. I could do it with just one. Everybody understand what I'm saying? So this one you could have slightly less, but it's better to have more in your construction and be sure of it than to have too little and not get full credit for it. Do those constructions make sense? Okay, then we did two more things in this unit. This was a kind of a long chapter. The next thing we did was the distance formula. So the distance formula, remember, is d equals square root, big huge square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so if you have 2 points that are like endpoints of a line segment, this is the length of that line segment. So if I had like A is the point -3, -4, and B has coordinates -7, -9. Then the length of AB would be the square root of, now you have to be careful about signs, like pluses and minuses. You're subtracting x values, so it's going to be -3 minus -7 squared plus -4 minus -9 squared. And then you just evaluate this. This is going to be -3 plus 7, which is really 4 squared, is 16. And then -4 really plus 9, which is 5. 5 squared is 25. So this ends up being the square root of 41. But remember, sometimes this ends up being a radical that can be simplified. In this case, this is simplest radical form. But you have to remember how to do radical form so that You could simplify this if necessary. Like if this was, for example, the square root of 45, and we just got through doing the Pythagorean theorem, which also uses simplest radical form. So this should be fresh in your memory, but if I have like the square root of 45, this would end up being 9 times 5, which would be 3 radical 5. So you have to remember that that sometimes applies here. 41 happens to be a prime number, so it doesn't simplify, but sometimes it will. Okay, and then the last thing we did in this unit was the midpoint formula. So the midpoint formula is just the average of the x's and the average of the y's. x1 plus x2 divided by 2, y1 plus y2 divided by 2. You just average the x's and you average the y's. Now, quite often they'll give you, instead of just saying, here's 2 points, find the midpoint, they might give you one of the endpoints and the midpoint, and you have to find the other endpoint, right? So like, for example, if they give you a situation like this, and this is not drawn to scale, but suppose we have segment AB and its midpoint M. Okay, they might give you the coordinates of A are 8, -6, and the coordinates of M are 7, -7, and you have to find the coordinates of B. So you could still use the midpoint formula. Like you could say this is x, y, and we're just trying to find x and y. Well, remember, the average of the x coordinates, which would be 8 plus x divided by 2, they have to equal 7, the x coordinate of the midpoint. And the average of the y values of A and B, which would be -6 plus y divided by 2, that has to equal what? -7. So now we just have 2 little simple linear equations that we have to solve. This would be like cross multiply. So you get 8 plus x equals 14, and x would be 6. And here, again, cross multiply, -6 plus y equals -14. If you add 6 to this, you get y equals -8. So the coordinates would be 6, -8. Does that make sense? So that's it for unit 1, okay? Tonight's homework is just like, I don't even know if there's one of every single type of question, but there's pick several different questions, one of each, and you just try and, as always, like on Delta Math, if there's a topic that you're not very good at, do more problems. Like you can do 4 problems if I only assign 1, that's okay. But just remember this test that we're taking next Friday and the following Monday, there's no test corrections allowed. So you want to make sure that you're pretty comfortable with the material, and they're going to be the exact questions on Delta Math, like always. So I don't want you to think that I'm going to try and shock you by giving you like a really hard question. It's the same questions that you're doing your homework on. So, I mean, you can be as prepared as you want to be for it. Any questions about that? Okay. So that's it for today.